Okay, so for number 4, you guys were given 2 facts. You were given that angle 1 is complementary to angle 2. And if you remember, what's the definition of complementary angles? Yeah, there are 2 angles that add up to 90 degrees, right? So angle 1 and angle 2 are complementary. So you know that angle 1 and angle 2 add up to equal 90, right? So that's why I put that little corner right there. Then you're also given this other fact. You're given that BE bisects DBC. So BE, this angle here, bisects DBC. So what does that mean if BE is the angle bisector? What does that mean? What does that mean in terms of angle 2 and angle 3? They're congruent. Thank you. So this is what they're asking you to prove. Prove that angle 1 and angle 3 are complementary to each other. Which makes sense, because if angle 1 is complementary to angle 2, and angle 2 has the same angle measure as angle 3, then that means that if I add 1 and 3, that's also going to get me 90 degrees, right? So now you just have to come up with a proof. And remember, we're just learning 2-column proofs right now, because it's like a way to be organized, but we're going to go into paragraph proofs and flowchart proofs later on. So BE bisects DBC. How do I know that BE bisects DBC? How do I know that? It was given to me up here, right? And if you guys notice, they actually used the second fact. What we've been used to so far is using the first fact, right? But you can use it in any order that you want. So we're going to say that that was given. All right, so how do I know that angle 2 is congruent to angle 3? How do I know that these two are congruent to each other? Definition of the angle bisector, right? Good job. I heard somebody in the back. So definition of angle bisector. And you should have already written this down on number 4. But if you didn't or you got it wrong, go ahead and write the correct statement. So if angle 2 is congruent to angle 3, doesn't that mean that the measures are the same as well? Or that their measures are congruent as well? Yes? I see some of you guys shaking your head. Some of you guys are just looking at the screen. So the measure of angle 2 is congruent to the measure. Forgot to write measure right there. Of angle 3. And they already pre-filled the definition of congruent angles. So cool. So far, all we've said is BE is the angle bisector. I know angle 2 and 3 are congruent because of that definition. And then I also know that their measures are congruent. Cool. So angle 1 is complementary to angle 2. How do I know that 1 and 2 are complementary to each other? It was given. That's correct. It's at the top. It was given. So now we're using that first fact that they gave us. So if angle 1 plus angle 2 is complementary, what does that equal to? 90 degrees. Cool. And what's that a definition of again? Complementary angles. So you would just say definition of complementary angles. So if you guys notice, now we're going to use, I'm going to use a different color. I'll stick to yellow. So do you guys remember that the measure of angle 2 is congruent to the measure of angle 3? So since the measure of angle 2 is congruent to the measure of angle 3, we can substitute that into this statement right here to get us the 6th statement. The measure of angle 1 plus the measure of angle 3 is also 90, right? So remember, when we substitute something in, we could write substitution property. And depending on what we do, we can also say it's transitive property, but transitive property is when both things are equal to something and then we, like A equals B, B equals C, so then A equals C. So in this case, it would just be substitution because we're substituting one component. It's not transitive property here. So when we substitute, we find that the measure of 1 plus the measure of 3 is 90 degrees. Therefore, the measure of angle 1 is complementary to the measure of angle 3, or 1 is complementary to 3. So you would write that in your last statement. So angle 1 is complementary to angle 3, and that's already pre-filled for you in number 4, definition of complementary angles.